Hi there, in this video I'm going to discuss simultaneous equations. So what are they? Simultaneous equations are two equations with two unknowns. Let me give you an example. So in example 1 we have two equations. For the first equation we have y minus x is equal to 2. Second equation reads 2x squared plus 3xy plus y is equal to 8. So these are simultaneous equations because we have two equations and the two unknowns are x and y. Okay, so let me show you how this is solved. So back to the paper and pen. So here is example 1 part A. So what I usually do is I name my equations 1 and 2. Okay, so that's a good starting point. And if one of your equations is linear, so linear means the powers of the terms are 1, okay? And if the other equation has a power other than 1 or is a quadratic most commonly, okay? What I would say is take the linear equation, so take the equation where the powers of the terms are 1, and it's entirely up to you, so you can rearrange for y in terms of x, or you can rearrange for x in terms of y, depending on which unknown you want to calculate first. Okay, so what I'm going to do is I'm going to take equation 1, the linear equation, so using 1, so always look at your linear equation. I'm going to find y in terms of x, so y minus x as it stands is 2. So if I rearrange for y, y is 2 plus x. So I'll rearrange the y in terms of x because I'm going to calculate x first. Okay, so let me replace the y's in equation 2 now by 2 plus x. So if I put y is equal to 2 plus x into equation number 2, so in other words, if I replace the y's in equation 2 by 2 plus x, we're going to have 2x squared plus, so a plus 3x, so 3x, open a bracket, y is going to be replaced by 2 plus x, okay, plus the y, so plus, and y again is replaced by 2 plus x, and that is equal to 8 on the right hand side. So if I expand the brackets, I'm going to have 2x squared plus 3x times 2 is 6x, 3x times x is 3x squared, plus the 2 plus the x, and that is equal to 8. So in this case, let's try and make a quadratic equation. So if we take all of the terms to the left hand side, so if I take the 8 to the left hand side, and let's simplify and add the like terms. So 2x squared plus 3x squared is 5x squared, okay? 6x plus x is 7x, okay? 2, taking the 8 to the left hand side, so 2 minus 8 is minus 6, and that in turn equates to 0. So now I have a quadratic, so you can solve this quadratic either by using the quadratic formula, but this quadratic can be factorised. So you can factorise the left hand side, and the factors being would be 5x minus 3 and x plus 2. So these should be the factors for the quadratic, okay? So bearing in mind the factors, you have two solutions for x. So either 5x minus 3 is equal to 0, and if you rearrange from here on, so taking a minus 3 to the right, 5x is equal to plus 3, x therefore is 3 over 5. So this is the first value of x for this equation. We have another value, so either 5x minus 3 is equal to 0 or x plus 2 is equal to 0. So if x plus 2 is equal to 0, if I rearrange from here on, taking the 2 to the opposite side, x is minus 2. So these are our two values for x for this pair of equations. Now don't stop here, because you need to work out the corresponding values of y. So what I'm going to do is, you can put your x values into either of these two equations, okay, or you can use this equation over here, okay. So I'm going to name that equation 3, and 3 comes from 1. So I'm going to use equation 3 because it's rearranged in terms of y already. So let me put the x values into equation number 3. So equation number 3 is this one, which reads y is equal to 2 plus x. So let's firstly find the corresponding y when x is equal to 3 over 5. So when x is 3 over 5, when I put the x value and replace it in this equation here, y is equal to 2 plus x, which is 3 over 5, okay. 2 plus 3 over 5 as a fraction, 13 over 5. So this should be the y value for when x is 3 over 5. So let me continue, say, over here. Let me continue here as we have another value of x, so let's find its corresponding y value. So when x is equal to minus 2, when I replace in equation 3, we're going to have y is equal to 2 plus x, x being minus 2, and when I simplify, 2 plus minus 2 being 0. So that is the corresponding y value for when x is minus 2. Okay. So we have two solutions all in all. So the first solution is when x is 3 over 5, y is 13 over 5. So when x is 3 over 5, y is 13 over 5. So that is your first solution. And second solution, when x is minus 2, the corresponding y is 0. Okay, so you can express your solution in this form, and when you express your solution, okay, write the terms in order of the alphabet, so meaning x before y. This should be the solution to example 1 part A. So back to the screenshot. So in this case we have another example. So example 1 part B. So 1 part B reads y is equal to x squared plus 1 and 2y plus 2 is equal to x squared plus 6x. So back to the paper and pen. So here are the two equations, so good starting point, as I said earlier. Name your two equations. We have one of the equations which is already rearranged for y, okay? So what I'm going to do is simply replace the y by x squared plus 1 in equation 2, okay? So it's already rearranged for y, so it makes sense by using that rearrangement and replacing the y by x squared plus 1. Let's find the x values first. So if I put y is equal to x squared plus 1 into equation number 2, so if I replace y by x squared plus 1 in 2, I'll get 2 into y is x squared plus 1, plus the 2, and that is equal to, on the right hand side, x squared plus 6x. Now let me expand the brackets, so 2 times x squared is 2x squared, okay, and 2 times 1, which is 2, plus this 2 over here, so plus this 2 here, and that in turn is equal to x squared plus 6x on the right hand side. So that is equal to x squared plus 6x on the far right. Now what I'm going to do is, as I did before, let's try and form a quadratic. So let me take these two terms over to the left hand side. So if I move these terms to the left, we're going to have 2x squared minus x squared, and that is x squared, plus 6x to the left hand side is minus 6x, 2 plus this 2 here is 4, and that is equal to 0. So this should be the form of the quadratic. Now, unfortunately, unlike part A, we can't factorise this quadratic, so we can't factorise this. We need to use the quadratic formula. So remember the formula, x is minus b, plus or minus square root b squared minus 4ac all over 2a. Okay, so for the formula, a, the coefficient of x squared is 1, b, the coefficient of x is minus 6, c, the constant in the quadratic is plus 4. So with these values in mind, let's substitute them into the formula, giving us x is equal to minus, b is minus 6, plus or minus square roots, b, which is minus 6, don't forget the squared, minus the 4, a being 1, c being 4, divided by 2 into and a, which is 1. So from here on, let's expand the brackets. So minus into minus 6 is plus 6, plus or minus square root. Minus 6 squared is plus 36. Minus 4 times 1 times 4 is minus 16, divided by 2 into 1, which is 2. Okay, and if I simplify further, I'll have 6 plus or minus square root. 36 minus 16 is 20. Okay, divided by 2 in this case. So root 20, so that is the same as root 4 times root 5, using the fact that 4 times 5 gives us 20, and one of the roots gives us a whole number of 2. So in this case we're going to get 2 root 5. Okay, so that's what you should have for root 20 being simplified. So let me continue along the line. So I'll have 6 plus or minus root 20, which is 2 root 5 over 2. And what I'm going to do here is, if I take out a common factor of 2 from the numerator, I'm left with 3 plus or minus root 5 divided by 2. And I can then cancel the 2's in the numerator and denominator to give us x as 3 plus or minus root 5. So these are the x values for the pair of equations. So let's calculate the corresponding y's. So what I'm going to do is put these x values into equation 1. Okay, so if I put the x values into equation number 1, so 1 is y is equal to x squared plus 1, so that's equation 1. So first of all, let's see what happens when x is 3 plus square root of 5. So when x is 3 plus root 5, y is equal to x, which is 3 plus root 5 squared plus 1. Okay, now I'm going to leave my answer in the form of a root, so let me expand first of all. So y will be, when I expand this bracket, I'll get 9 plus 6 root 5 plus 5, okay, from the expansion of this bracket only, plus the 1, okay. And when I simplify further, 9 plus 5 is 14, 14 plus 1 is 15, so 15 plus 6 root 5. So that should be the the corresponding y for when x is 3 plus root 5. Now let me continue. Let's see whether I've got some space here. So I've got some space here to use. So let me continue here. So when x is equal to 3 minus root 5, so if I replace x in the same equation, y is equal to x, which is 3 minus root 5 squared plus 1. And if I expand this bracket, we should get 9 minus 6 root 5 plus 5 plus this 1, and simplifying further, 9 plus 5 is 14, plus 1 is 15, minus the 6, root 5. So that is the corresponding y for when x is 3 minus root 5. Okay? So let me continue over here. So I have some space here. So I've got two solutions. Okay, two values of x and two corresponding y values. So the first solution is when x is 3 plus root 5, so 3 plus root 5 for x, corresponding y is 15 plus 6 root 5. So I have 15 plus 6 root 5 for the corresponding y. And another solution when x is 3 minus root 5, so 3 minus root 5, corresponding y is 15 minus 6 root 5. So 15 minus 6 root 5 for y. So here are the solutions for part B. So we have another example. So part C reads y is equal to x squared plus 5x, and the second equation is y minus x is equal to 12. So back to the paper and pen. So let's name these equations 1 and 2. So I'm going to put y is equal to x squared plus 5x into equation 2. Y equals x squared plus 5x into equation number 2. So here's number 2. We're going to have y, that is x squared plus 5x minus the x, and that is equal to 12 on the right hand side. Okay. Now if I move my terms to one side, so if I take the 12 to the left hand side, we can form a quadratic. So we're going to have x squared, 5x minus x is 4x. Taking the 12 to the left hand side is minus 12, which is equal to 0. Okay. Now this equation can be factorized, or you can use your quadratic formula to find the values for x. So if I factorize, so the factors being x plus 6 and x minus 2, so these should be the two factors. So I've got two values for x, so either x plus 6 is 0, that means that x is minus 6, so one of the x values, or x minus 2 is 0, that means x is plus 2. So these are the two values for x. Now it's up to you how you would calculate your y values. You can put the x values into equation 1, or you can put the x values into equation 2 to work out the corresponding y's. I'm going to put my x values into equation 1. So if I put the x values into equation number 1, so number 1 reads y is equal to x squared plus 5x. So firstly, let me see what happens when x is minus 6. So when x is minus 6, I'm going to replace y is equal to x, which is minus 6 squared, plus 5 into x, which is minus 6. Okay, so if we continue, minus 6 squared is 36. 5 into minus 6 is minus 30, so the y value is 6. So this is the y value corresponding to x being minus 6. And let's find the corresponding y when x is 2. So when x is 2, when I replace in the same equation number 1, I'm going to have x, which is 2 squared, plus 5 into x, which is 2. Okay, so if we simplify here, y will be 2 squared being 4, 5 into 2 is 10, y then will be 4 plus 10, 14. Okay, so hence we've got two solutions. So the first solution, when x is minus 6, y is plus 6, and the next solution, when x is 2, corresponding y, 14. So this should be the solution to part C. Okay, so that completes this example, and that sadly ends the video. So I hope you found this video helpful. I hope you found it useful. If you did enjoy the video, a like is very much appreciated. Do plenty of practice questions, and I hope to see you again. Thank you.